All right, now let's have some fun in the coordinate plane and see if we can use the ideas of congruent triangles to actually resolve this question. So we have lots of givens here. I'm given a whole bunch of points. So here are the coordinates, A, B, C, D, E, and F. And I want to take a look at these angles. I want to take a look at the angle BCA and show that it's congruent to angle DFE. Well, the first thing I want to do is sort of graph them. Now, I have to admit that I've done this in advance, but I haven't labeled the points. So we're going to figure out the points together. But I wanted to get the lines nice and straight. So, okay, a little teeny bit of cheating on my part, but I know that it was not really bad. Okay, let's take a look. A. A is -3, -6. So I go over -3 and then down to -6, and so this is A. Where is B? Well, B is -3, 6. So that's -3 and then up to 6. So that's B. And where's C? C is -7, and then I go up 4. That's C. Okay, now what about D? Well, D is 3, 8, so I go over 3 and up 8, so that's D. And I put the rest of the points in. It turns out this is E, and this is F. Okay, great. Now, what are the angles that we're trying to take a look at? The angles we're trying to take a look at are B, C, A. So I want to take a look at that angle right there. I want to keep my finger there, and I want to show, hopefully, that it's congruent to angle DFE. So I want to show those two angles are congruent. How in the world could I possibly do that? All I know are the coordinates of the vertices of these triangles. But if I could show that these two triangles are congruent, then I know corresponding parts are going to be congruent. And if these two are corresponding angles, then I'd be home free. So there's going to be a sub-question. And the sub-question is, can we first figure out if these two triangles are congruent? How are we going to do that? Well, since I know the coordinates of all the vertices, I could actually use the distance formula to actually compute the length of each of these sides. And if I could show that this side has the same length as this side, and this side has the same length as this side, and this side has the same length as this side, then I know the two triangles are congruent by side, side, side congruence. So what we have to do now is compute lots of distances. Well, I don't want to do them all because you can try them on your own, but I'll do a few of them just to sort of show you how this would look. So let's compute the distance between D and F. So DF, okay, remember the formula. It's square root of, and it's a long square root, of the differences in the x, so 7 minus 3, all squared, plus the differences in the y's. So the coordinate here is -2 minus, and the coordinate up here is 8, all squared. And now what does this work out to be? Well, let's figure this out. So 7 minus 3 is 4, and 4 squared is 16, plus -2 minus 8 is -10, squared is 100. And so I see this equals the square root of 116, which is not a whole number, but that's okay. This length right here is the square root of 116. Let's actually compute, just for fun, this length, and let's hope that it works out to be the same. So let's see this one. So now I'm going to find the length AC. Well, what is that? Well, that's a square root. And how do we do this? What I'm going to take here is the x-coordinate here, which is -3 minus -7. That's the x-coordinate here, all squared, plus the y-coordinate here, which is -6 minus the y-coordinate here, which you see is 4. And I square all that, and that square root goes all the way through. I couldn't quite fit it all on there. Big square root, big square root, big square root. Now, what do we get? Well, so this is going to give me a 4 squared, which is 16. And this gives me a -10, which when I square it gives me 100. And this is sounding a little familiar now. I see the square root of 116. So check it out. these lengths are equal. So that's great. Now we can do the exact same method with this side and find out that its length turns out to be the square root of 20. You can check that if you want. And this length turns out to be the square root of 20. You just have to use that distance formula with these points and these points. And finally, this turns out to equal 12, turns out to have a whole number length, and this is 12. Look, corresponding sides, in fact, are equal in length, which means that the corresponding sides are congruent. So these two triangles are congruent by side, side, side. That means that corresponding parts are congruent. And you'll notice that this angle C is opposite the side that has length 12, which means that the corresponding angle would be F, which is opposite the side that's 12. Therefore, these angles, are really congruent because the triangles are in their corresponding parts. We just proved a real neat theorem. Congratulations, and enjoy proving theorems for yourself.